In section 3.5, number 21, we are supposed to find an equation of the tangent line to the curve at the given point. And we have to use implicit differentiation, which they told us in the instructions, but we could see ourselves because we can't solve this equation for y just in terms of x. So we're going to take the derivative with respect to x across the equal sign. And once we have solved for dy dx, we're going to go ahead and plug in the ordered pair to get the slope of the tangent line. And then we'll use that slope with the point pi over 2 pi over 4 to come up with the tangent line equation. Okay, so to take the derivative, we're going to need the product rule on each side as well as the chain rule ultimately. So again, if you're very practiced in using the product rule, you don't necessarily have to label first and second maybe anymore. So on the left hand side, using the product rule, that is the first times the derivative of the second, and the derivative of sine of 2x requires the chain rule. The derivative of the sine of x is cosine of x. Derivative of sine of 2x is cos 2x times the derivative of 2x, which is 2. And just to make sure you don't accidentally think that the 2 is being multiplied by the 2x, you could put that 2x in its own set, the cos 2x in its own set of parentheses. So that's first times derivative of the second plus the second, sine of 2x, times the derivative of the first. Now the derivative of y with respect to x is actually dy dx. It's 1 times dy dx. And on the right hand side we need the product rule again. So we have the first times the derivative of the second. Now the derivative of the cosine function in general is the negative sine function, but now we have the negative sine of 2y times the derivative of 2y, which is 2, times dy dx. So again, the implicit differentiation says anytime we take the derivative of a term that includes y, at the end we're going to have to multiply by dy dx. That's a form of the chain rule. So that's first times derivative of the second plus the second times the derivative of the first, and the derivative of x with respect to x is just 1, and since I'm out of space I won't write that explicitly here. Okay, and then our next job is to get all the terms with dy dx together on one side of the equal sign, and I tend to put them on the left. And while I'm at it, I can try to do a little bit of simplifying. So I already have the sine 2x times dy dx on the left, and now I want to take that whole other term from the right side that's outlined in blue and bring that over to the left side. And since I see that there is a negative sign there, I know I'm going to add it to the left hand side. And as I said, while I'm at it, I'll try to neaten it up a little. So I'm going to be adding 2 times x times the sine of 2y times dy dx. And I'll just stare at it again for a minute and make sure I didn't forget anything. I have the dy dx, I have the 2, I have the sine 2y, and I have the x. And then anything that does not include a dy dx, I want to gather together on the right side of the equal sign. So the cosine of 2y is already there, and then I want to now subtract over the piece that's outlined in pink from the left-hand side, which currently on the left side is positive, so I want to subtract it to get it over to the right-hand side. So that would be minus 2y times the cosine of 2x. And now I'm going to factor dy dx out of the left-hand side, and that will leave me with sine 2x plus 2x times the sine of 2y. And I haven't changed anything on the left-hand side. And last but not least, to get dy dx by itself, so I'm finding dy dx because that is the slope of the tangent line. I'm going to divide both sides by the term that's multiplied by the dy dx. So I have cosine 2y minus 2y times the cosine of 2x, and that's all going to be divided by the sine of 2x plus 2x times the sine of 2y. All right, so I have dy dx, and dy dx evaluated at the point I was given, the tangent point pi over 2 pi over 4, is the slope of the tangent line that I'm trying to find. And I was already given the point, pi over 2 pi over 4. So this is the last piece that I need to be able to come up with that tangent line equation. Alright, so I have to evaluate this dy dx at the point pi over 2 pi over 4. So basically, in that dy dx expression that I found, every x is going to be replaced by pi over 2, and every y is going to be replaced by pi over 4. So I have the cosine of 2 times pi over 4 minus 2 times pi over 4, replacing every y with pi over 4, times the cosine of 2 times pi over 2, replacing x with pi over 2, that's in my coordinates, over the sine of 2 times pi over 2, replacing x with pi over 2, plus 2 times pi over 2, replacing x with pi over 2, times the sine of 2 times pi over 4, replacing the y with pi over 4. Okay, so now I got to remember my trig. Well, let me simplify what I'm taking sine and cosine of here. So I have the cosine of 2 times pi over 4, that's pi over 2, minus pi over 2 times the cosine of pi, divided by the sine of pi, that's 2 times pi over 2 is pi, plus 2 times pi over 2 once again is pi, times the sine of 2 times pi over 4, which is pi over 2. Okay, so what do I have here? The cosine of pi over 2 is 0, minus pi over 2 times the cosine of pi, which is negative 1, divided by the sine of pi, which is 0, plus pi times the sine of pi over 2, which is 1. So this is pi over 2 divided by pi. I believe that is 1/2, because the pi's cancel out, right? So pi over 2 divided by pi is pi over 2 times the reciprocal 1 over pi, and the pi's cancel, and I'm left with 1/2. So that is m, the slope of my tangent line. So now I have a slope m of 1/2, and I have a point that was given to me, pi over 2 pi over 4. So I'm going to use my point-slope form of the line to get the equation of the tangent line. Let me just move this down so I have a little more space. So that is y1 plus m, that's 1/2, times x minus x1. That's the equation of the tangent line. And again, you can simplify that into y equals mx plus b form if you want to, or you can leave it like that. Either way is fine. The computer WebAssign should accept it either way, as long as you've typed it in correctly. I believe if we were to simplify this, it would just turn out to be y equals 1/2 x. That's just using my eyeballs and not writing anything down, so I could be wrong, but you can check on that.